National Electrical Code Section 430.111 states that disconnecting means shall be provided to disconnect each motor and its controller from all ungrounded conductors. It's crucial to understand that this section does not mandate the use of a fused disconnect. A fused disconnect serves as one avenue for providing overcurrent protection, yet it isn't the singular or universally required method. In situations where dual-element time delay fuses are employed to deliver overcurrent protection following Section 430.112a on, utilizing a fused disconnect becomes optional. While fused disconnects offer supplementary safeguarding against short circuits and ground faults, they aren't obligatory under the National Electrical Code in such scenarios. When dealing with motor installations, adhering to the National Electrical Code is paramount. Section 430 encompasses comprehensive guidelines for motor circuits, motor control circuits, and motor protection. Understanding these requirements ensures safety and code compliance. Disconnecting means are essential components in motor circuits, providing a way to isolate the motor from the power supply for maintenance or emergency situations. These disconnecting means must be readily accessible and capable of being locked in the open position for safety during servicing. Overcurrent protection is a critical aspect of motor protection, preventing damage from excessive current due to overloads or short circuits. Fuses and circuit breakers are common overcurrent protective devices, each with its own characteristics and applications. Dual-element time delay fuses are specifically designed to withstand temporary overloads without interrupting the circuit, making them suitable for motor start in applications where inrush currents are common. These fuses provide both overload and short-circuit protection, safeguarding the motor and circuit components. Section 430.111 of the National Electrical Code mandates a disconnecting means for each motor and its controller. This disconnecting means must disconnect the motor and controller from all ungrounded conductors, providing a complete isolation of the motor circuit. The disconnecting means must be readily accessible and located within sight of the motor and controller, unless specific exceptions are met. This requirement ensures that personnel can quickly and safely disconnect the motor in case of an emergency or during maintenance. The disconnecting means must also be capable of being locked in the open position, preventing accidental re-energization of the motor circuit during servicing. This lockout/tagout procedure is crucial for worker safety and compliance with OSHA regulations. While Section 430.111 requires a disconnecting means, it does not explicitly state that the disconnecting means must be fused. A fused disconnect combines the functions of a disconnecting switch and overcurrent protection in a single device. This offers convenience and space savings, but it is not the only acceptable solution. Overcurrent protection can be provided separately using fuses or circuit breakers located upstream of the disconnecting means. The choice between a fused disconnect and separate overcurrent protection depends on factors such as cost, space constraints, and specific application requirements. Section 430.112a on allows the use of dual-element time delay fuses for overcurrent protection of motors. These fuses are designed to handle the high inrush currents associated with motor starting while still providing protection against overloads and short circuits. The dual-element construction provides both a time delay for temporary overloads and instantaneous protection for short circuits. When using dual-element time delay fuses, the fuse rating must be carefully selected to provide adequate protection without nuisance tripping during motor starting. The National Electrical Code provides guidelines for selecting the appropriate fuse rating based on the motor's full load current and other factors. In situations where dual-element time delay fuses are used for overcurrent protection, a non-fused disconnect can be used as the disconnecting means required by Section 430.111. This provides a cost-effective and code-compliant solution for motor installations. However, it is important to ensure that the overcurrent protection is properly coordinated with the motor and circuit components to prevent damage or hazards. The use of a fused disconnect can provide additional protection against short circuits and ground faults. This is particularly beneficial in applications where the motor is located in a harsh environment or where there is a high risk of electrical faults. A fuse disconnect can also simplify troubleshooting and maintenance by providing a readily accessible point for disconnecting and testing the motor circuit. Ultimately, a decision of whether to use a fuse disconnect or a non-fuse disconnect with separate overcurrent protection depends on a variety of factors, including code requirements, application specifics, and personal preferences. It is important to carefully evaluate all options and select the solution that provides the best balance of safety, performance, and cost-effectiveness. In addition to the disconnecting means and overcurrent protection requirements, the National Electrical Code also addresses other aspects of motor installations such as motor control circuits, motor enclosures, and grounding. Motor control circuits must be designed to provide safe and reliable operation of the motor, including starting, stopping, and speed control. Motor enclosures must protect the motor from environmental factors such as moisture, dust, and corrosion. Grounding is essential for providing a low impedance path for fault currents, minimizing the risk of electric shock. Understanding and complying with all applicable requirements of the National Electrical Code is crucial for ensuring the safety and reliability of motor installations. Consulting with a qualified electrical professional is recommended for complex or critical applications. In summary, while Section 430.111 mandates a disconnecting means for each motor, it doesn't explicitly demand a fuse disconnect. When dual-element time delay fuses provide overcurrent protection as per Section 430.112a, a non-fused disconnect is permissible. This offers a compliant and potentially more economical approach, but a fuse disconnect can provide additional protection in certain situations. The National Electrical Code serves as a comprehensive guide for motor installations, covering various aspects like disconnecting means, overcurrent protection, control circuits, enclosures, and grounding. Adherence to these regulations is vital for ensuring safety and code compliance. The selection of the appropriate disconnecting means and overcurrent protection method should be based on a careful evaluation of factors such as application requirements, cost considerations, and desired level of protection. Consulting with a qualified electrical professional is always advisable for complex or critical installations. Understanding the nuances of the National Electrical Code, particularly Section 430, is paramount for anyone involved in the design, installation, or maintenance of motor systems. By carefully considering the specific requirements of each application and selecting the appropriate components and methods, you can ensure safe, reliable, and code-compliant motor installations. Remember that the National Electrical Code is a living document that is updated regularly to reflect changes in technology and industry practices. It is important to stay informed of the latest code requirements and to consult with qualified professionals to ensure compliance. In the context of the specific scenario involving two washing motors, one rated at 125 amps and the other at 60 amps, each motor requires a disconnecting means as per Section 430.111. These disconnects are to be mounted within sight of the motors, typically on an adjacent wall, and must be weatherproof due to the environment they are located in. The selection of dual-element time delay fuses, rated at 175% of the amperage, is a valid approach for overcurrent protection. Given this overcurrent protection strategy, the use of fuse disconnects is optional, not mandatory. However, consider the advantages of fuse disconnects such as enhanced protection against short circuits and ground faults. The decision ultimately depends on a comprehensive assessment of the specific needs and circumstances of the installation. It is also good practice to create and maintain accurate documentation of the electrical system, including wiring diagrams, equipment specifications, and overcurrent protection settings. This documentation can be invaluable for troubleshooting, maintenance, and future modifications to the system. Regular inspections and testing of the electrical system are also essential for ensuring its continued safety and reliability. These inspections should include visual checks of wiring, connections, and equipment, as well as electrical testing to verify the integrity of the installation and the proper operation of overcurrent protective devices. By following these best practices, you can help to ensure the safety and reliability of your electrical system and protect your facility from electrical hazards. In conclusion, The decision to use fused or non-fused disconnects for motor installations is not always straightforward and depends on a variety of factors. Understanding the requirements of the National Electrical Code, particularly Section 430, is essential for making informed decisions and ensuring code compliance. Consulting with qualified electrical professionals is always recommended for complex or critical installations.